All right, in this lesson, I want to discuss two things. I want to discuss what a reference angle is, and that's something that we've actually touched upon before, but I do want to formally define it and make sure we're comfortable finding reference angles. And then secondly, I also want to extend our knowledge of trigonometric functions so that we can find and evaluate trig functions of any angle and using just coordinates as well. So let's start first with the idea of the reference angle. So what is the reference angle? The reference angle is simply the positive acute angle that is formed by the terminal side of an angle theta and the x-axis. So for example, I had some angle, and suppose my angle were, its terminal side ended here. This is my angle theta. My reference angle would be this angle here. It's the remaining angle between that terminal side and the closest x-axis. And even when our reference angle, or even when our angle is negative, so for example, I said something like this, if this were our angle theta here, our reference angle, we would still indicate it to be the positive angle between that terminal side and the closest x-axis, okay? So let's do a couple of practice problems with this to make sure, really sure that we understand these, okay? So let's go ahead and work through a few of these. What about when your angle is 300 degrees? Well, you don't have to sketch this out, but if you need to, you could see that hopefully, I actually make that a little bit smaller. 300 degrees would be in quadrant number 4. It'd be this angle here. I know it's past 270 degrees, so this would be 300 degrees. Well, what would be my reference angle? How many degrees until I get to my closest x-axis here? Well, this would be 60 degrees. So my reference angle would be 60 degrees. Okay, let me jump to something like number 4 first before I do number 2. What about when your angle is 213 degrees? Well, 213 degrees, well, that angle, you could say 213 degrees, is a little bit past 180. Specifically, how many degrees is it past 180? It's past 180 by 33 degrees. Okay, so our reference angle here would be 33 degrees. That's the angle between that terminal side and the closest x-axis. Okay, let's go to number 5. What about 144 degrees? Well, again, that angle here is 144 degrees. What's the angle between that terminal side and the closest x-axis? Well, that would be 36 degrees. Okay. Well, what about when we're dealing with an angle in radians? So 3.1 degrees. If you remember our discussion about the radian, we know that here, this negative x-axis is pi radians. So that means, if I kind of zoom in on this, 3.1 radians is actually really, really, really close to that x-axis, that negative x-axis. So what is this tiny sliver of an angle here? We would say that that angle alpha would be whatever pi minus theta is. In this case, we would, let me write this, pi minus 3.1. That's the exact answer. Our reference angle is pi minus 3.1. Its approximate value is 0.014159, and there's some more decimals after that. There's an infinite number of them, actually, or infinite number of places after that, but we'd say that it's pi minus 3.1 radians. Okay, go ahead and pause the video and try these two problems here. Negative 135, hopefully, after you've had a chance to try these, is this angle here. So its reference angle is 45 degrees. And then negative 2 would be this angle here. I should draw this. This angle here, negative 2 radians. And if I know that this is pi again, how would I find this angle here? Well, that's effectively just the difference between pi and 2. So I can say that my angle is just simply pi minus 2. That's going to give us this reference angle here. Okay? All right. So hopefully that helps clear up any misunderstandings or on what a reference angle actually is. And now that we've talked about that a bit, let's actually now go into the main bulk of our lesson, which is to discuss trigonometric functions of any angle. And just as a quick recap, we said that when we're evaluating a trigonometric function of some angle theta, we know that the opposite side we can use to describe as our y, or our vertical distance from the x-axis. X is our horizontal distance, also gives us our cosine of our angle. And our r value here, which is our hypotenuse, when we're dealing with angles in the unit circle, we say that R value, we treat R as 1. For this reason, I'm going to say R is always positive, because R is simply going to represent the distance of that point from the origin. So I'm going to say R is always positive. Okay, and you'll notice that in the first quadrant, y and x are both positive, and since R is always positive, that means all of our trig functions are going to be positive in quadrant 1. Well, what about in quadrant 2? Let me actually zoom in on this since we're working exclusively here. In quadrant 2, our y is still positive, but now look, our x is negative. Well, that's the case. That means sine is always going to be positive in quadrant 2, right? Because our x value is negative. That means any angle that uses the adjacent side, or x, is going to be negative. That includes both cosine and tangent. When we're down in quadrant 3, our x is still negative, our r is always positive, but now our opposite side y is negative, which means that the only trig function that is positive here is tangent, right? Because sine and cosine would be negative here. And then finally in quadrant 4, our y is negative, our x is positive. So here we would say that the only trig function that's positive is cosine and its reciprocal, okay? Something that might help you remember, some just kind of mnemonic device, you'll hear a lot of students say, all students take calculus, which is not true. But if you're taking this course, you may have hopes of taking calculus in the future. So that's just an easy way to remember which trig functions are positive in which quadrants. And the important thing here is just to make sure we understand why. Think about the relationship between these side lengths of these triangles that we can draw and their trig functions, okay? All right, so let's try some practice problems. Let's look at this first one here. We're told that let -2, 3 be a point on the terminal side of theta. Then find the sine, cosine, and tangent of that angle. So let's sketch this point first. So if we're -2, 3, we're in quadrant 2. This is -2, this is +3. Okay, there's our terminal side, our point lies on it, and this is our angle theta. Now here's the deal. Normally, if we were given an angle, we could just look at the y and x values using our unit circle understanding and just evaluate the trig functions there. But we don't know the angle. All we're given is a point. And on top of that, if we look at the coordinate values, we see here that this height has to be 3, and this distance from the origin horizontally has to be -2. Well, if that's the case, there's no way that our hypotenuse is 1. We actually have to find our hypotenuse. So let's actually calculate that. We'd say 3 squared plus -2 squared is equal to r squared. So r squared has to be equal to 13, and r we can then say is root 13. Now that we know what our hypotenuse is, we can then evaluate the trigonometric functions. So sine of theta, and again, to reiterate, we don't know what theta is, but we do know that when I take the sine of this angle, I can evaluate my opposite over my hypotenuse, or my y over my r, which simplifies to 3 root 13 over 13. Okay, let me make that a little smaller. What about cosine of theta? Well, cosine is going to be -2 over root 13, which simplifies to, -2 root 13 over 13. And then finally, let's just do tangent. Tangent of theta is going to be opposite over adjacent, which is just 3 over -2. Okay? And then finally, the other type of problem that we haven't really done yet is something like this next problem here. So let's take a look at this one. So given that this trig function, sine of theta, is equal to -4 over 5, let's stop there for a second. Ask yourself, what quadrant could we be in? Well, if our sine is negative, we know that we could be in quadrant 3 or 4. So we could be able to draw an angle that looks something like this, -4 over 5. Or in quadrant 4, where this is -4 and our hypotenuse is always 5. So just by this bit of information, all we can do is isolate it to 2 quadrants. But if we take a look at this second part, which tells us that tangent of theta is positive, well, in these 2 quadrants, we know that tangent is positive in quadrant 3. Remember, all students take calculus. So if tangent is positive in quadrant 3, that completely rules out this quadrant here, okay? So we know for sure that our angle is somewhere here in quadrant 3, and I can just kind of arbitrarily draw that right there. Well, if that's the case, if our angle is, you know what, and in fact, let me actually draw it this way. It's okay, theta can be a negative angle. If that's the case, then do we have what we need to evaluate cosine and cosecant? Yeah. We know that the cosine of theta is adjacent over hypotenuse, or x over our hypotenuse r. And we could do the Pythagorean theorem here. We could also identify that this is a Pythagorean triple. This is a 3, 4, 5 triangle. So the cosine of this would be negative 3 over 5, adjacent over hypotenuse. Well, what about cosecant of theta? And actually, we could have done this problem without drawing the triangle. Cosecant is simply the reciprocal of sine. Okay. And the last thing that I just want to mention here, this will be the last set of problems, and I'll let you practice the others on your own, is to evaluate the sine and cosine functions at the angles here. Now, you'll notice that all of these angles here are not in any particular quadrant. These are called quadrantal angles because they lie on an axis. So just quickly run through them. We know that the sine of 0 is going to be equal to 0. The sine of pi over 2 is equal to 1. Sine of pi is equal to 0 because it's on the x-axis. Sine of 3 pi over 2 is equal to negative 1. Okay? Well, let's take these values, let's take this, and let's rewrite this with cosine now. Okay? Cosine of 0 is equal to 1. Cosine of pi over 2 is 0. Cosine of pi is equal to negative 1. And cosine of 3 pi over 2 is equal to 0. These are just quadrantal angles. All you need to be looking at are the x and y values at all of these quadrantal angles. We know this is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. So as we go for the sines, we're just looking at all of the y's. As we go through the cosines, we're just looking at all of our x's. Okay? All right. Well, go ahead and try the rest of these problems here, and you can check your solutions with what I have uploaded to my website. And good luck.